Hi, this is day 8 of Algebra 2 Summer School Honors. I wanted to go through a few sample problems with you. Um, First one is we're supposed to change this to be written as a logarithm. And I'm going to write up at the top, if I have a base raised to a power of it's equal to a number. And the definition of a logarithm is that the log in a base be of a number is equal to that power. So this is written as an exponent. To write it as a log, we would say the log in base 8 of the number 512 is equal to 3. Does that work? Sure. What does you raise 8 to get to 512? 8 cubed is 512. Here we have the log in base 5 of 1 over 125. What do you raise 5 to get to 125? That's negative 3. We're doing the same thing with this guy, only it's going to be the reverse. Instead of writing it as a log, we're going to write it as an exponent. We have 5 as the base. We're going to raise it to cubed. That will give us 125. And we have 1/5. When we raise that to the negative 2, that's the same as 5 to the 2 power when you flip it because of the negative sign. And that's equal to 25. In this, we have the base, the log of the base of this base. I could rewrite this as n minus 5 times log in base 11 of 11, which is equal to n minus 5. And this fellow, I'm going to raise 10 to both sides of this equation. Can I do that? Can I take 10 and raise it to things that are equal and make it equal? Sure. So if I have 10 to the log of base 10 of x squared plus 1 is equal to 10 to the 1 power. This is the inverse operation here, so I'm end up with x squared plus 1 is equal to 10. When I subtract 10 from both sides of the equation, I get x squared minus 9 is equal to 0. And I can factor this using the difference of squares. If you remember our property when we did, it's a special case of factoring. X plus 3 and x minus 3 is equal to 0. If you don't believe it, you should try doing the box, x plus 3, x minus 3. We end up with x squared negative 9. And here you'll have a plus 3x and a minus 3x, and these two cancel. These two will equal to 0. So my answers, x is equal to either negative 3 or it's equal to positive 3. Now, you can't have a log of a negative number, but if I put in negative 3 for x, both of these work. So this is actually the correct solution. Here we have a similar situation. I'm going to take 7 and raise it to both sides of this logarithm. When I do that, this cancels. I end up with x squared plus 36 is equal to 100, or x squared minus 64 is equal to 0, x plus 8, and x minus 8. The difference of squares, once again, is equal to 0. So I have x is equal to 8 or negative 8. And both of these are actually valid because if I plug it in, I can't have a negative log. Why can't you have a negative log? Let's think about that for a minute. If I have a log in, let's say, base 7 of a negative 343, what power do you raise 7 to in order to get to negative 343? That's what this is saying. Why can't you have a negative number? Any positive number raised to a power will never be a negative number. Any positive number, if you raise it to a negative number, it'll be a fraction. It won't be a negative number here. So this is impossible. This is undefined. That's why you cannot have the raise a power, you can't have a log of a negative number. On a graph, if you were to graph the exponential growth function looks like this, and it goes through this point. If you were to take my x is equal to y value, and I were to graph the inverse of it, it would look like this. And here you can see there are no negative x values, and that's why you cannot have the log of a negative number, because they don't exist. That's not to say that you can't have a log of a negative x, because a negative x, if x is negative, then you have a log of a positive number. Now here we plug this into our calculator. When I do that, I'm using the log button, and I'll do the log of 7.2, and I get 0.8573, and that's rounded to the fourth decimal place. Here we have an exponent, and we're looking for the value that's in the exponent. What strategy would you use to solve this? Well, that's why we're studying logs, so that you could use logs. So I'm going to take the log in base 10 of both the left side and the right side. If I don't put 10, it means it's assumed base 10. So here I have the log in base 10 of 4 to the 3p is equal to the log in base 10 of 10. What is log in base 10 of 10? What do you raise 10 to get to 10? You raise it to 1. This is equal to 1. On the left side, I'm going to write this with the exponent on the outside, log 3p of log of 4. Now we'll divide both sides by 3 and by this to get the p by itself. Get p is equal to 1 over 3 times log of 4. And that's log in base 10. If I plug this into the calculator, 1 divided by 3 log of 4, I get 0.5537 when it's rounded to the fourth decimal place. 6.5 rounded to the fourth is 7. Now, I've got two different things. How would you solve this? Well, it's got an exponent, and the exponent is where my variable is. I need to find this exponent. I could set this equal to each other and then later change it. I don't think I'll bother with that. I'm going to raise log of base 10 because I know on my calculator I've got log of base 10. So I'll take log of base 10 of 7 to the p plus 2 is less than or equal to log in base 10 of 13 to the 5 minus p. And I can move the exponent to the outside, so I have p plus 2 times log of 7 is less than or equal to 5 minus p to the log of 13 times the log of 13. If I divide both sides by log of 7, and I subtract 2 from both sides of this equation, I'm going to have, let's find a number for this. Log of 13 divided by, 13, make sure you put the parentheses in, divided by log of 7. That gives me the number 1.3181 rounded to 4 decimals. If I multiply that times 5, and then I subtract 1, and also add 0.3181p. I'll add that to both sides, multiply this by 5, and subtract 2. So I get 2.3181p is less than or equal to, and 5 times this number, minus 2, gives me 4.5906. I'm going to divide both sides by 2.3. I get p is less than or equal to, I'm going to divide this now, 2.3181, and I get 1.9803. And that looks good to me. But the idea behind how to do it is something that you all should know and recognize how to do. Here I want to know what this value is. I'm going to rewrite it as 2 times log in base 4 of 1.6. I'm going to use my change base rule to get, this is 2 times log in base 10 of 1.6 divided by log in base 10 of 4. When I plug this into the calculator, I get 2 times log of 1.6, close parenthesis, divided by log of 4, and I get, for my answer, 0.6781, rounded to the fourth decimal place. I think that's it. Good luck and success.